So it's really important to note what I mean when I say unpaired electrons. And this is going to require us going back to something that you've done in chemistry. Okay, so think back to chemistry class. And filling of electron orbitals. What you probably remember is there are different energy levels. So there is the, let me see how low I can go on here. There is the 1s orbital, there is the 2s orbital, there is the 2p orbital, and so on, right, etc. Okay, so for example, let's take an atom such as carbon. So let's use carbon as our example. So let's use carbon as an example. So we know carbon has 6 electrons. It has 6 protons, it has 6 neutrons, and it has 6 electrons. So we're going to focus on where those electrons would exist in the orbitals of a carbon atom. Well, we have 6 electrons, and we know that the capacity for the 1s orbital is 2 electron max. We know that the 2s orbital has a capacity of 2 electrons max, and we know that our 2p orbital has a capacity of 6 electrons max, right? But we only have 6 electrons total. So we're going to start at the s orbital, and we're going to have in our s orbital 1 electron with spin up and 1 electron with spin down. So this happens because it's energetically favorable for there to be an electron with spin up and an electron with spin down. So I'm going to use these arrows, so let's make a little key here. This arrow up means spin up. This arrow here means spin down. Now I have 6 electrons in that carbon atom, so I've only exhausted 2 of them. So now I need to figure out where are the other 4 electrons going to go. Well, in our next energy level, we can put 2. So we're going to have 1 with spin up and 1 with spin down. And now that energy level, the 2s orbital, is full. But we can still fit 6 more electrons in our 2p. However, we don't have 6 electrons left. We've already exhausted 4 of them out of our 6. So we only have 2 left. Well, these electrons are not going to fill up, down. They're actually going to fill up, up. Because that 2p orbital gives those electrons more room to be away from each other. So they're not going to go right next to each other because we know electrons repel. So they don't want to be right next to each other. So these 2 electrons are going to get as far away from each other as possible, which is going to leave an opening right here and an opening right here. So we haven't fully filled that 2p orbital at all. But what you'll notice is now what we are left with in this atom is we have 2 unpaired electrons. And what I want to tell you is the presence of unpaired electrons is what gives an object or a material its magnetic properties. Okay, so let's make a note to ourselves. The presence of unpaired electrons, the presence of unpaired electrons, in other words, electrons with parallel spins, or the same spin. Is the cause of magnetism, or the cause of magnetic properties. So the more unpaired electrons you have, or the more electrons you have with the same spin, the greater the net spin is. So let's make that note as well. So the more electrons that have the same spin, the greater the net spin, and therefore the greater the magnetism. Okay. Now what I just showed you here with the way these orbitals fill and the way they fill in the same spin state like this when they're not going to fill completely, this is something called Hund's rule. Okay, so I'm just going to write that right here. Hund's rule. Okay. So when you don't have enough electrons to fill an orbital, they will get as far away from each other as possible. So we'll look at a different atom really quickly. Let's say we had